Hello students, so today in this lecture I will tell you the ether as a protecting group for alcohol, and this is part 2. In my part 1 lecture I told you some of the ethers which may act as a protecting group for alcohol, for example benzyl ether, tertiary butyl ether, this THP, that is tetrahydropyrenyl ether, silyl ethers. So in this lecture I will tell you some more ethers which may act as a protecting group for alcohol. So let's summarize it first in the form of table. So protection as and reagent used, deprotecting agent, okay. Now first is methoxy methyl ether, and the reagent used, so short form for this is MOM, we call it a MOM, okay, and the reagent used for this is methoxy methyl chloride. So in short form I can write it MOM chloride, methoxy methyl chloride. So this may be used in presence of some base, for example diisopropyl ethylamine, or we call it a N diisopropyl ethylamine, or we can write in a short form diisopropyl ethylamine. Diisopropyl ethylamine can be written as a short form. For deprotection we use concentrated HCl. Okay. Now second one, so if we write the structure of methoxy methyl ether, then suppose we have a alcohol and we react it with a methoxy methyl chloride, then we get a structure like so this is methoxy methyl ether, okay, methoxy methyl ether, and we use a reagent methoxy methyl chloride. The second one is MEM, that is methoxy ethyl ether. This is methoxy ethyl ether, and in short form we call it MEM. So reagent used is MEM chloride, MEMCl, and we can use some base like sodium hydride may be used as a base. Again concentrated HCl, so concentrated HCl, as ethers are very stable one, so we use a concentrated HCl for the deprotection one. Okay, so now R so this is methoxy ethyl ether, and deprotection we write MEM chloride. Third one, benzyloxy methyl ether. In short form we call it BOM, BOM. Okay, so reagent used is benzyloxy methyl chloride in presence of some base, sodium hydride may be base, deprotecting agent, concentrated HCl can be used. So I write the structure, so benzyloxy So this is benzyloxy methyl ether. Okay, benzyloxy methyl ether and benzyloxy methyl chloride can be used. Now, next one is para-methoxy benzyl ether. Para-methoxy benzyl ether. So in short form we may write para-methoxy benzyl ether, and para-methoxy benzyl chloride can be used as a reagent in presence of base. Okay, now here if you write this one, para-methoxy benzyl ether. This is para-methoxy benzyl ether and para-methoxy benzyl chloride. Now some other ethers which can be used for the protection of alcohols, for example some other methyl ethers which can be used for protection of alcohol. Other methyl ethers are like simple methyl ether, suppose it is CH3OR, ROH, that may be react with this is suppose the reagent used is iodomethane. Iodomethane may be used, or we may use a dimethyl sulfate as a reagent to get a methyl ether. So dimethyl sulfate can be used as a reagent. Okay, and the ether form that will be R ROH that will react with this to give this one. This in presence of sodium hydride may be used as a base. Now next one, azomethane, that is CH2N2, that can be used. Azomethane in presence of tetrafluoroboric acid. Tetrafluoroboric acid can be used here. So the mechanism it will be clear. And for this the deprotecting agent, it may be boron tribromide can be used as a deprotecting agent, or HBr in acetic acid can be used as a deprotecting agent. Okay, so here again we will get a methyl ether. Okay, so methyl ether we may get a deprotecting agent. So sorry, this will be methyl ether. Again we will get a methyl ether as a deprotecting agent. Okay, so this is the summary. This is the brief of the various reagents used as a various reagents and the various ethers which can be used as a protecting group for alcohol. So let's discuss one by one. So now let's discuss all type of this ether one by one. And first one is methoxy methyl ether. that is mom. So if I take one of the example, suppose this is one of the alcohol, and if you want to protect it, then we can use a mom chloride for the protection. We can use a mom chloride. Okay, so via this SN2 reaction, this chlorine will leave out and we will get an ether. So this in presence of the base, as I told you, in presence of base diisopropyl ethylamine. Diisopropyl ethylamine can be used as base to extract this acidic proton, and we will get the ether, mom ether. Okay, so this is mom ether, and if you see, then this is mom, and this part, that is methoxy methyl, this methoxy methyl ether, this is the mom. Methoxy methyl ether, this is mom, MOM. Now this can be deprotected. This can be deprotected in presence of concentrated HCl, and this will be protonated. This oxygen that would be protonated. So the oxygen that will be protonated is, this is the oxygen that will be protonated, and here, so this carbon oxygen bond that will break. This carbon oxygen bond will get broken, and we will get our alcohol back plus this mom chloride. We will get the mom chloride also back. In the same way, we can use methoxy ethyl ether also. Suppose I use methoxy ethyl ether, that is MEN. So let's take one of the example of alcohol. Suppose this is our alcohol, and if we want to protect this OH group, then we may use the MEN chloride. This is methoxy ethyl chloride. Methoxy ethyl chloride. So if I write, then this will this is methoxy ethyl chloride. So I written wrong. Sorry. So this is methoxy ethyl, and this would be chloride. This is methoxy ethyl chloride. Now this will attack over here, and chlorine will leave out, and what we will get? We will get the protected alcohol. So minus HCl will leave out, and oxygen, and this will attach here. Okay, like this. Now further it can be deprotected by using concentrated HCl. Okay, so what we can write? This one will put in, and we will back get OH plus Okay. No, this is the correct one. Okay. So this is methoxy ethyl ether. Now third one, let's take a benzyloxy methyl ether. Benzyloxy methyl ether. That is bomb. And let's take one of the examples. Suppose if we have a this OH group that we have to protect. Okay, so we may use here benzyloxy methyl chloride. Okay, so this in presence of base, we may use a base here, and this group, OH group, that will be protected. Like this. Now further it may be deprotected. It may be deprotected. Using concentrated HCl, and we will get this again. Okay, so like this. So in the same way, we may use the paramethoxy benzyl ether. Now let's take the example of this other methyl ethers. Suppose if we have any alcohol and if it reacts with iodomethane, then we may get a, or suppose it is phenol. Suppose it is phenol. Then what we get? So this can be protected. Okay. So it is anidol that is formed. In the same way, this alcohol may be protected in presence of dimethyl sulfate. This may be protected in presence of dimethyl sulfate. Sodium hydride as a base. So methyl ether is formed here, and plus we will get and further it may be deprotected in presence of concentrated HCl, and we will get ROH back plus H3Cl. In the same way, we may use a diazomethane. Suppose if we have an alcohol, then we may use diazomethane. So this diazomethane, it may act as an electrophile as well as a nucleophile. So if we have a CH2N2, this is diazomethane. Okay, so if I write the structure, then the structure looks something like this. This is a plus, this is a minus. Okay, so this exists in a resonance form. Like this. Okay, so This may act as a electrophile as well as a nucleophile. So suppose this is the diazomethane. Then first of all, this diazomethane in presence of tetrafluoroboric acid. So this is tetrafluoroboric acid. So this will form CH3 and 2. And in the next step, here this will leave out. Okay, so this will leave out. We have ROH, then this N2 will leave out. Okay, so what you will get? You will get CH3 this N2 is removed, and we will get methyl ether. We will get the methyl ether. Okay, ether. Then in presence of boron tribromide, it can be deprotected. So this boron, this having the vacant orbital, so it will form, this bromine will leave out, okay, and after the hydrolysis, what we get? We get alcohol, okay, plus this HBr we will get, and we will get boronic acid. Like this. So this would be the product. Okay, so thank you.